Hello everyone. This week we're going to be talking about angles of elevation and angles of depression. We learned a little bit about trig functions last week, and we're going to be using those again this week to help with our angles of elevation and angles of depression. So the first thing, what is an angle of elevation and what is an angle of depression? An angle of elevation is the angle formed by a horizontal line and the line of sight to the point above the line. So if I look at this diagram down here, my angle of elevation is the angle here to my line of sight. The angle of depression is the line of sight to a point below the line. This angle will be my angle of depression, looking down. An important thing to note is that because the angle of elevation and angle of depression are alternate interior angles, those two angles actually have the same exact measure. Those two angles are congruent. So the angle of elevation is congruent to the angle of depression. If I look here, let's classify each of these angles as an angle of elevation or angle of depression. So I'm going to look at my parallel lines here, here, and then one up top. Let's look first down here at the ones below. So as I see this eyesight, I can see that from this man, he can look up or he can look down, which would make angle 2, looking up, an angle of elevation, and angle 3, looking down, an angle of depression. Looking at the bottom of the tree, you can look up to the man to see that this is an angle of elevation, and then the top of the tree down to the man to see this is an angle of depression. So angle 1 and angle 3 are angles of depression, and angle 2 and angle 4 are angles of elevation. So let's look at this first example. Suppose a plane is at an altitude of 3,500 feet and the angle of elevation from the airport to the plane is 29 degrees. What is the horizontal distance between the plane and the airport? Round to the nearest foot. So I have a plane and I have an airport. I'm going to draw a triangle in between those two. So I've got an angle of elevation from the airport to the plane of 29 degrees. So I know the angle of elevation from here to here, looking up, this angle right here would be 29 degrees. I also know that the plane is at an altitude of 3,500 feet. So I know the distance from the ground to the plane is 3,500. I want to find the horizontal distance between the plane and the airport. So I want to find this distance. If I look at my angle right here, I want to find a trig function that relates that angle to the sides. I'm given the opposite side and the adjacent side. I am not using the hypotenuse at all, because this is a right angle. The trig function that goes with opposite and adjacent would be tangent. The tangent function is opposite over adjacent. So I can write my trig function as tangent of, well, I know my angle is 29 degrees. Opposite is 3,500 over adjacent, which is x. I need to find what that measure of x is. So in order to solve for x, to get that out of the denominator, I'm going to multiply both sides by x. So those will cancel out. I get x times the tangent of 29 equals 3,500. And in order to get x by itself, I'm going to divide the tangent of 29. So those will cancel out. I will get x equals 3,500 divided by the tangent of 29. I'm going to switch over to my calculator here. 3,500 divided by the tangent of 29, and I get about 6,314. I'm going to round to that nearest foot. I'm not going to use the decimal points, the decimal values. So 6,314. So x is about 6,314 feet. The horizontal distance between the plane and the airport is about 6,314 feet. So let's look at another example. A climber stands at the edge of a cliff that is 115 feet wide. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. How deep is the cliff at this point? Round to the nearest foot. So again, I'm going to draw myself a triangle. I know that the cliff is 115 feet wide. So the base of this triangle is 115. The angle of depression from the edge to where she stands to the bottom of the opposite side is 52 degrees. So the angle of depression, I need a line here. That's 52 degrees. I want to know how deep the cliff is. I want to find this value over here, how deep the cliff is. Now, my measure, my angle degree, my angle of depression is outside of my triangle. I'm going to get rid of that just so we can see this a little easier. Since that angle of depression is outside my triangle, and because I know the angle of depression and the angle of elevation are congruent, because they are alternate interior angles, I can write the 52 degrees right here. Using that, I can find the measure of the depth of the cliff. So if I look at this angle, 52 degrees, I see again that I'm given the opposite and the adjacent, which means we're going to be looking at the tangent again. So the tangent of 52 equals x over 115. In order to get x by itself, I need to multiply both sides by 115. So I get 115 times the tangent of 52 equals x. So let's go back to our calculator. 115 tangent of 52, and we get about 147. So I know the depth of the cliff is about 147 feet deep. Let's do one more example. A ranger in a fire tower sees another fire and the angle of depression to the fire is 3 degrees. What is the horizontal distance to this fire from the base of the tower, round to the nearest foot? So I have a fire spotter. The angle of depression to the fire is 3 degrees. So I'm going to draw this horizontal line because the angle of depression is 3 degrees. I need to know the horizontal distance to this fire from the base of the tower. So the horizontal distance here, I label as an x. And it looks like I forgot to label the height of the tower, which is 90 feet. I meant to type that up there, I apologize. So the height of the tower is 90 feet. So again, I'm given the angle of depression is 3 degrees. So the alternate interior angle to that would be my angle of elevation. And again, if I look at this, 3 degrees, I'm given the opposite and the adjacent. So again, we're going to be using tangent. So the tangent of 3 equals opposite over adjacent. We'll multiply both sides by x. So x tangent of 3 equals 90. And we'll divide by the tangent of 3. So x equals 90 divided by the tangent of 3, which, go back to Desmos, 90 divided by tangent of 3, which gives you 1,717. 1,717. So the horizontal distance from the fire to the base of the tower is about 1,717 feet. I'm going to look back at this problem again for 1 minute, and I want to show you an alternate way we can write our trig function. So again, I'm going to label my sides 90, x. The angle of depression is 3 degrees. So because these lines are parallel, and because I know this is a 90-degree angle, I should also have a 90-degree angle here. So if you wanted to, instead of using your alternate interior angles, you could have found the measure of this angle. 90 minus 3 has 87. So instead of using my 3 degrees, I could have used 87. Using this angle would make this side the opposite and this side the adjacent. So I could have done tangent of 87 equals x over 90. When I multiply by 90, I get 90 tan of 87 equals x. And if I type that in, I get the same value, 1,717. So that is just another method you could use to solve the same problem. Using that angle of depression, I could have either labeled my opposite angle of elevation here, my alternate interior angle, or the angle right next to it as 87. Those complementary angles, those 90-degree angles. And that is angle of elevation and angle of depression. As like always, be sure to ask your teacher if you have any additional questions.